Objective 2 in topic of exponent rules is to use exponent rules to simplify rational exponents and radical expressions. So this is the objective where we're gonna call upon the exponent properties or rules that we learned about in objective 1 and put them into action. All right. I've listed steps in red that are very useful to follow step by step if one of these problems presents itself like this. But the challenging thing with this objective is that all of these problems kind of present themselves differently. So you just have to know the properties and apply the properties. All right. So I'm going to do example 4, and then I'm going to do example B, and then I'm going to ask you to do 2 on your own to try your knowledge. And if you notice, this one down here looks a little bit different than the example I'm about to do, but the rules always interact the same way, always play out the same way. So in red, I've listed the steps that I always think through when I approach a problem. So please follow my thinking on this, because this is the process I go through when I try to simplify one of these. The first one is to always simplify inside the parentheses first, if necessary. If I look at the problem I'm given, I see a gigantic parentheses. I see a whole bunch of stuff within the parentheses, and then I see a power. So the first thing I know to do is I cannot interact with that power yet until I clean up or simplify what's in the parentheses. Now that leads me to think, what is in the parentheses? I see a numerator and a denominator, or a top and a bottom, with variables on them. So the first thing I want to consider, is there any multiplication I can do in either the numerator or the denominator to clean it up? And I want to do multiplication before I do division. So I will notice that in the denominator, there's no multiplication because there's no same bases. Again, you can only multiply bases if they're the same. There's a y and an x, you can't do anything with it. So I can't do anything in the denominator with multiplication, but I can do multiplication in the numerator. I have an x cubed, but then I have 2 y's. I have a y to the 5/5 times y to the 5/3 times y to the 5/3. And don't freak out about the rational exponents. You can just use your calculator if necessary to do that math. But that tells me that y times y, I can do multiplication. So my first thing about simplifying, to start the simplification process, is I'm going to multiply the numerator. The top, I'll put. All right? So I'm going to rewrite everything and show you that math with the new math being done. So I know there's a 2/3 up top, the power of 2/3. I know there's still a denominator, because I didn't touch anything like that, or I didn't touch the yx squared yet. All I'm doing is cleaning up this piece, the multiplication that is necessary in the numerator. I didn't touch the x cubed, I just bring it down. And this is the process I want you to start doing. If you don't do anything with anything yet, just bring it down and rewrite it. But I am going to change my y power. All right? Now, base times base, y times y, I add these powers up here. 5/3 plus 5/3. If you remember from adding fractions, it has to be the same denominator. And in this case it is. So when that is the case, you can add the numerators and leave the denominators alone when you're adding. But in order to avoid that thought process, because this objective is difficult enough, I'm just going to use my calculator. So I'm going to pull up my calculator, and I'm going to add these fractions, 5/3 plus 5/3, in my calculator. I'm going to use a parenthesis, so please always put fractions in parentheses. 5 divided by 3, close the parenthesis, plus open parenthesis 5 divided by 3. And then I hit enter. It's going to give me a decimal. I have to hit math and then enter again. So my new power of my y's is 10/3, that you just saw on my calculator. So this now becomes y to the 10/3. That is my first step. Now I have multiplied. There's nothing left to multiply. So I move to division. Base divided by base, I subtract the powers. Now I'm going to say divide. This is my divide step. I'm still going to put parentheses, and I know 2/3 is still out there waiting to interact with everything. But I have an x over here and an x over here, base divided by base. Now yes, you might ask, well, they're in different spots. Does that matter? No, multiplication, you can move things around, the property still remains the same. I have a base on top with the same base on the bottom, so I have to divide those bases and subtract their exponents. So I'm going to write x to the numerator first, so the numerator's power is always first, so 3 minus 2, and then y to the, this case it's a fraction, and I'm going to put that in parentheses to remind myself to put it in parentheses in the calculator, y to the 10/3 minus y to the, in this case it's 1. It's not written, but I know it's 1. So, this is my new step. I have x to the 3 minus 2, 3 minus 2, and y to the 10/3 minus 1. So I'm going to go ahead and do that math in my third step, alright? So I know that x is still in parentheses, and if you notice, in step 2, there's no more denominator. Everything comes up to the numerator to do this math. Technically it's still over 1, but I don't have to put that necessarily. So x to the 3 minus 2 becomes x to the 1, and then y, and I'm going to do this math on my calculator again, just to show you how I would actually go about this. So if I pull up my calculator, I have to subtract those two powers. So I have 10/3, put that in parentheses, minus 1. Alright, because base divided by base, this base of y to the 10/3 and y to the 1, I have to subtract their powers. 10/3 minus 1 equals a decimal. I have to hit math, enter, enter, and I get 7/3. So now my y is to the 7/3. Close the parenthesis, and this is still all being raised to the 2/3. Now I can go ahead and start having this power interact with what's inside the parentheses, because I have done the division. So all of my step 1 is now done. I have simplified everything that it can be simplified within the parentheses. Alright, so now I can start bringing in the power to every term within the parentheses if necessary. And in this case, it definitely is necessary. I'm going to bring that 2/3 into that x. It's going to interact with that power. And into the y, it's going to interact with that power. So I'm going to rewrite what this looks like right here, my fourth step. And I know power raised to power, I multiply the power, so it becomes x to the 1 times, parenthesis, 2/3. And then y to the 7/3 in parentheses times 2/3. Parentheses. Now I can do that math, and my final answer, x 1 times 2/3 is just 2/3, anything times 1 is itself. And then y, you could put this in your calculator, but you can also, it's easier to multiply fractions, you just multiply straight across. 7 times 2 is 14, so I'll put that equals 14 over 3 times 3, which is 6, and then 14 over 6 reduces to 7 over 3. And this is my final answer. Again, you could also put this in your calculator exactly like you see it, hit math, enter, enter, and it'll give you 7/3. Now, it took me 5 steps. I had to follow, and I just had to go to this now. There was none of this happening, alright? Sometimes there will be more work to be done, but in this case, I am done. X to the 2/3, y to the 7/3. And again, it is difficult, but if you take it step by step and just think through the rules that exist, you should definitely be able to arrive at an answer that I just arrived at. Now, one more example that I'm going to have you try to on your own. And I just want to show you this one because it does play itself out a little bit differently. So I'm going to draw a little separator box. The only thing that's different here that I didn't write in my red steps is this. It's a radical sign. The first step then, if you ever see a radical sign, is you have to switch it to rational. Alright? So that radical needs to go away, and I need to write it in rational form instead. So this math, square root of x, remember it's the square root and it's x to the 1, they're just not written, can be written then as x to the, this is the root, r, this is the power, right? So r goes below, and power goes above. So x to the 1/2 is the same thing as the square root of x, but I need it in rational form to apply these properties. So now I'm going to rewrite everything that I have after I did that. So I didn't touch the 8x to the 5th, all raised to the 1/3. And now that's being multiplied by 2x to the 1/2 instead of the square root of x. So that is my first step. So if you notice down here, you're going to have to do that to this one. That's your first step before you apply any of the rules. Now let's think through this process. The first step always is to simplify inside the parentheses if necessary. I'm looking at my parentheses, 8x to the 5th. There's nothing to simplify. There's no base times base or base divided by base or anything raised to the 0. Nothing to simplify. 2x to the 1/2, same. I don't have to do this first step because it's not necessary. So I can jump down to the next step, bring the power into every term if necessary. In this case, this does happen. The power of 1/3 is going to interact with that 8. It's also going to interact with the x to the 5th. In this case over here, there is no power, so I don't have to do this step to this chunk. So I'm just going to bring this chunk down and rewrite it. So my second step is going to be showing this math because I did have a power to interact with this inside the parentheses. So it becomes 8 to the 1/3 x to the, remember, power raised to the power, you multiply the power, so it becomes 5 times parenthesis 1/3. All of that is still in a parentheses, and it's being multiplied by the thing I didn't touch, 2x to the 1/2. All right, now I'm going to clean this up and then rewrite it. All right, so 8 to the 1/3, I can put that in my calculator, and you should remember how to do that from a couple videos ago. 8 to the 1/3 is 2. All right, if you don't remember how to do that, just put 8 and then raise it to the 1/3 in parentheses and hit enter on your calculator. It should give you 2. Now, x to the, if I add these on my calculator, I'll take out my calculator, and here's the math of that 8 to the 1/3, exactly like I wrote it. I hit enter, it gives me 2. Now, if I want to do this, x to the 5 times 1/3, I just do 5 times, in parentheses, 1 divided by 3. Close the parentheses, hit enter, gives me a decimal. I do math, enter, enter, and it gives me 5/3. All right, put your calculator away for a second. So I'm going to write now x to the 5/3. This is still in parentheses, and now it's finally being multiplied by that piece I haven't touched yet, 2x to the 1/2. In this case, then, I have a coefficient times by a coefficient. 2 times 2 is 4. Then I have a base times a base. Base times base, you add their powers. 5/3 plus 1/2. My calculator out again, and I already put in 5/3 plus 1/2. I put parentheses around my fractions. I hit enter, gives me a decimal. I hit math, enter, enter, and my final answer is 4x to the 13/6. So now, my fifth and final step, I'll write my final answer. 4x to the 13/6. And I am done. Please pause this video and try A and the other number 1 on your own. Take through the steps I've written in red. Think through yourself, is there anything to simplify in parentheses? If so, I need to do that. If not, then I can move to the next one. I have to distribute the power into all the terms that exist within the parentheses. After I do that, then I do multiplication, and I see in number 1 it is a fraction, so I'll do multiplication in the numerator if necessary, and then multiplication in the denominator if necessary. If none of that is necessary, then I go to division, and then I'll do division from the numerator to the denominator. So pause the video and go ahead and try these on your own. Alright, here are the answers you should have gotten and the steps I took to get there. The first answer, x to the 13/16, and then this one is a little bit more complicated. It took 5 steps, and if you notice down here, I flipped these because They were both negative, so one had to go to the top bottom and then bottom